All right. Without further ado, Joanna, it's all yours.
Yes, thank you so much, Brent. I'm really happy to be here. Brent just asked me last week to come and give a talk, kind of piggybacking off of the adventure y'all had in at the Elizabeth Learning Center. Um, and I wanted to title my talk, "Who Are Your Neighbors?" Because something I've been thinking about is um the one thing I really love about restoration is actually the community aspect. And you all are a really great community at CNPS and really investing in your community in many different ways. And really wanted to just think about what it means to be a good neighbor in your own community. And thinking about like what is the definition of a neighbor? We may not always be physical neighbors. Actually, is anybody, this is going to be an interactive session, just FYI. Is anybody, raise your hand if you actually physical neighbors? Anybody? Is anybody actually like next door
Like
neighbors?
right next door or same community?
Maybe same street?
Oh, I'm not.
No, not same street. Same community.
Yeah,
Hmm.
yeah, right here.
Okay. Couple you. Nice. Yeah, and so even though you're not physical neighbors, I think you all probably consider yourself neighbors or neighborly. And I just think about the definition or like the examples of neighbors, like the Good Samaritan, right, where Jesus is asked, like, I have to love my neighbor as myself, but who's my neighbor? And Jesus describes this story of this Good Samaritan who sees somebody in need and decides to help them. Doesn't know them previously, but just decides to help them. We can also think of Mr. Rogers, will you be my neighbor? Right? It's that invitation of coming together and saying, hey, I really want to live life with you and live community with you. And so being a good neighbor is really all about relationships. And that's also what ecosystems are about, is understanding all the interconnected relationships between everything living in an environment. So we're going to talk a lot about different neighbors today, and want to start with talking about the neighborhood you just visited. How many people actually went to the Elizabeth Learning Center? I get raise of hands of that too. Okay, maybe not the majority of you. Oh, a couple. Awesome, cool. I'm really sad I missed it, because I have heard of George's work before and really think he's doing really awesome work. But since not everybody has been to the that vernal pool site before, I just did want to give a quick introduction to vernal pools. And so vernal pools are seasonally flooded, isolated, temporary wetlands, and they're only fed by rainwater. So in those crazy winter storms that we got, these little depressions in the landscape fill up with water because there is a subsurface impermeable soil layer that allows the water to stay like perched on top of that impermeable layer. So water pools in the winter, and then during the springtime, we get this beautiful combination of water still in the pool and then lovely sunshine. And that's when plants and animals grow and reproduce really quickly before the pools completely dry out during the summer. And so again, they're temporary wetlands where anything that's living in a vernal pool needs to be able to live half their life underwater and half their life with no water at all. And so that's what makes these ecosystems so special is these anything that living in a vernal pool does need to have special adaptations. And so lots of things that are found in vernal pools are only found exclusively in vernal pools. They're endemic to vernal pools. And so if we take a look back at what happens during the spring, we can take a closer look at some of the species we find. So in the deepest part of the pool that gets the most water, we can get these popcorn flowers, these woolly heads, this coyote thistle is something that's common in Santa Barbara. And then what's really interesting about vernal pools is they're drying out um, kind of sequentially. So there's this deep central zone, and then there's this transition zone that gets wet and then dries out pretty quickly. We can get some other flowers like a Downingia or an owl's clover. This is my favorite plant, is this owl's clover. It's so beautiful. And then there's even just like the boundary, the periphery of the vernal pool that just gets flooded during the storm and then really just dries up really quickly. And so there's other upland plants that are sometimes even more just grassland plants. We have butter and eggs, we have meadow foam, and we have tidy tips. The names of vernal pool plants are the best. It's one of the reasons why I love them. So we have these plants that can live in vernal pools, and we also have a lot of animals living in vernal pools as well. We have these fairy shrimp that Brent mentioned. Our aquatic insects that are swimming around in the vernal pool, tadpole shrimp also. And these guys, these adults are swimming in the pool, and then when the pools dry up, they're swimming around as adults, they lay their eggs, and then when the pools dry up, their eggs or their cysts can just lay in the dry landscape. And then it's like, just add water. And then they come to life the next winter and spring. It's amazing. We also have California tiger salamander in vernal pools. So they like to breed in vernal pools. And their juveniles are aquatic. And then they metamorphose into these adult salamanders that can wander around. There's also lots of frogs in vernal pools. Frogs are tadpoles in the pool and then become frogs. Um, and so there's all of these really special, so especially a lot of these animals are really endangered in vernal pools. And that's because vernal pools themselves are endangered. They're fast disappearing. Only 5% of historical vernal pools in California still exist today. So that's why restoration is really important, because we really want to figure out how to recover these pools and how to help them. So that's what's really cool about George's work is he's creating and restoring vernal pools in the area because vernal pools exist in oftentimes in grassland landscapes, which are these nice flat, fertile landscapes that have largely been converted to agricultural fields and to development, like college campuses. UCSB is built on top of vernal pools. The Elizabeth Learning Center is probably built on top of vernal pools. Most of LA is built on top of vernal pools. So it's really cool that George is really working to figure out how to restore these native habitats. So restoration, though, is really challenging, right? Like when something gets destroyed, having to pick up the pieces and try to fit them back together, there's a lot of challenges. Can I ask, or can I get some feedback from y'all? Tell me three things that you learned about George's pools, like the process of restoration or the challenges he faced, or just your favorite plant. Somebody unmute themselves and give me three things you learned.
This is David Berman.
Yeah.
So I went to George's school and very impressed with the student involvement that he has. Um, I think the take-home message is the fragility of it, because when it dries out, as you said, it just looks like mud, but
Yeah.
it's filled with life that's just waiting till you add water to come back. So, and there's a lot of different lessons, but was the single most important lesson to me, the fragility and the importance of it.
Yeah, so you said the student involvement, so that the students were being good neighbors and trying to steward this land. And then, yeah, the fragility of the ecosystem and figuring out like what does it mean to have a vernal pool as a neighbor when you know that some parts of the year it looks like a big brown mud spot, and then other parts of the year it looks like a gorgeous floral bloom. Thanks, David. Anybody else want to to um add to that or anything else you learned from George?
Hi, this is Ellen. I
Hmm.
also went on the field trip, and while the ecosystem is very fragile and definitely needs to be protected, it was also amazing to me how he was able to like resurrect it by bringing that inoculum that he got, and they just put it, and then it all comes back to life. So that sort of the opposite of fragility in a way. At the same time, it's amazing how long lasting it is. And, you know, I forget exactly how long he said, but he said they're drought adapted maybe for hundreds of years or decades anyway, where they can just wait until the conditions are right to emerge.
Yeah, exactly. They're really dynamic ecosystems and they change a lot and they can withstand a lot of different pressures. And it is really cool that sometimes it is as simple as just like, hey, they just need some of the propagules, some of the inoculum, some of the seeds, and then nature will do its thing and figure out how to resprout from the dead. Great. That's really awesome to hear what you guys have learned. And one thing, Ellen, that you said was also just the drought adaptedness of vernal pools and how they can kind of withstand different, like, I mean, they're adapted to California's historically very variable precipitation regime. But as we have come into the 21st century, we have actually seen a lot more drier years, a lot more variability, a lot more drought years in variability in our precipitation. And that also has come with a lot of other stressors, namely invasive species. And so this is actually a picture of a vernal pool, believe it or not, but it is highly invited by a lot of annual grasses that have come over from Europe. They came over mainly for like agriculture, for feed and stuff like that, and they've really outcompeted natives and taken over some of these landscapes, especially during dry years. And these vernal pools are adapted to some pressures, but they're definitely not adapted to invasive species, especially because these annual grasses are they produce a lot of thatch because they grow and die every year, and then when they die, all of this biomass that you see on the landscape it just becomes thatch. It just lays on the landscape, and some studies have actually shown that it doesn't decompose as fast as native thatch. And so we get this huge buildup of non-native thatch, and that actually promotes more non-native grasses to grow in its own thatch, but actually prevents natives from growing in its own thatch. And so this is a situation where these non-native species really are not being good neighbors, right? They're really just like taking over an area, taking over all the resources and not letting the natives grow. And that's why it's really a problem for vernal pools and why we really want to address it in a management in management actions. And so we can think about as humans, what can we do to actually be good neighbors as these native plants are facing these threats of invasive species? And sometimes we can look back and see how people have been good stewards, but good neighbors in the past, and that has actually brought in the relationship between humans, nature, and fire. And fire is a really good tool for actually getting rid of unwanted thatch. And so the native tribes in California regularly burned the landscape in order to clear out area to promote more regrowth. And there are some native species that are actually adapted to fire. They really like fire is actually a good neighbor for them. They really like fire. And so we can think about, well, there are some places where humans can reintroduce fire into an ecosystem. But in the vernal pool that I showed you covered in thatch, that was in Santa Barbara. And this is actually a zoomed out view of these vernal pools. And so I can't put fire in this landscape because it is surrounded by humans, and development and fire would pose a huge risk to these neighbors. But it's really interesting that we can see these ecosystems, these vernal pools, as part of this neighborhood. And this neighborhood is actually right next to UCSB, and those tall buildings in the back are actually dorms. And so there's a lot of energetic students in those dorms. And I was like, these are the neighbors that I want to interact with. And so I went into those dorms, recruited a bunch of undergrad interns and said, and talked with them and said, hey, how can we be good neighbors to this landscape here? And really addressing this issue of thatch buildup. And so that's where I got to some of my dissertation work of how do we address this thatch issue to help restore these native vernal pools. So my interns and I went out. I'm sorry. Interns and I went out with not with fire, but with huge rakes. And we raked out all of that thatch out of the vernal pool and really clearing out area for native plants to be able to recolonize. And again, this is really thinking about how can we actually engage in our ecosystem and be a good neighbor to our native plants. And this is how we decided we could make a nice home for them, we could clear out space for them, and then we could actually just plant more native species because these pools have actually been degraded in several ways. And so they're actually lacking a native seed bank. There aren't that many native seeds left in there. So I've got more interns and we collected a bunch of seed and then we spread the seed all around the vernal pools. And then I recruited even more neighbors, more interns, and we took data on how our actions really affected the ecosystem. And we kept track of all the different plants that we could find in these vernal pools. And we did this raking and seeding and monitoring for 15 pools for 4 years. And so I actually worked with a lot of people. I just want to spend some time to thanking all of the people that I worked with and being able to engage with all of these neighbors. A lot of them had not heard of vernal pools before, even though they lived right next door. And so it was really exciting to me to be able to invite these people into their neighbor vernal pool and really contribute to the ecosystem in a positive way. Okay, so what did we find with these actions that we engaged in our vernal pools? Ecosystems. So this raking treatment. So we took data on control pools where we did nothing. We just left them covered in thatch so that we can compare them to the ones that we raked out thatch. And I'm showing you, we didn't do this just once. As I said, we did this over 4 years. So 2019 was pre-manipulation, and then we did 4 years of thatch removal. And so if we were being good neighbors, if this was a good way to be a neighbor, we would want to see the thatch removal plots having higher native plant percent cover. That's what's on this y-axis is how many the cover of native plants in our plots. So we want to see high purple bars is the goal here. What do we see? Ooh. Well, we see like some variability throughout the years. And I've plotted here also on this y-axis the annual precipitation. And I mentioned there's a lot of different, there's variation in the precipitation, and that really affects the native and non-native plants. And so we actually really only saw this higher purple bar saying there were more natives in the plots that we removed thatch from. But that was after 4 years of subsequent treatments. And so really the main takeaway that I found out this is that being a good neighbor means that you are committed to the landscape. So we didn't just do 1 year of engagement, we really engaged for 4 years and hopefully more. So we really want to be committed neighbors and to be good, engaged neighbors. I'll just show you one more graph from here where we're looking at native species richness. So the number of species that we found, because again, we added some native seed to some of the plots. Those are the green bars. And we see a similar story where only after 3 to 4 years of adding seed, we really see this higher native species richness in the plots that we actually added seed to. And just to let you know what fun plants we got to see out there. The main species we seeded and saw out there were Gardena Willows, this California gum plant, and Phalaris lemonii, this Lemon's canary grass. That you probably have seen Gardena Willows around the South Bay as well. But again, the take-home message from this research was really we needed to be committed neighbors and stay invested in the ecosystem. But then it was interesting to see like how like as we were engaging the landscape and learning more about it, it was really interesting to think about, well, what kind of neighbors, what neighbors are we looking for in this ecosystem? Like we found these two plants, these two species, we collected seed from the pools themselves. And so these were existing neighbors, and so we wanted to just really help them grow more. But we also saw more plants that we seeded more plants than these two species, and they didn't really come up that much. And we were wondering, why are some native plants benefiting from these manipulation treatments, and why are others not? And that really goes back to the question of who are my neighbors in this landscape, and thinking about how can we figure out who wants to grow here, what kind of what kind of water regime they want, or what kind of like open niche space they want. And so in addition to thinking about in addition to just going out there and looking at all the different plants out there, we also did some deeper dives into who could be our potential neighbors. And one way we dug deeper was actually digging deeper into the soil. We dug out some soil cores. So just a little clump of soil, and in that soil core is contains the seed bank of not only species that are germinating and growing, but just anything that's ever lived in here in the past like few decades. So we really think of a soil core as a seed bank showing us what could have grown there in the past. And plant seeds, a lot of plant seeds look alike, and a lot of plant seeds are really small. So it's really hard to identify all the different species just by like sifting through soil. And also my interns were like, I don't want to sift through soil. So find another way. I was like, okay, let's think about how we can look at these underground soil seed banks. And so we thought of using this method called eDNA, or environmental DNA, which is this idea that the environment contains these seeds, which contains DNA. And that's something that we can track and extract. So if you imagine the soil core, what we did, the soil core has fragments of seeds, fragments of DNA, and we washed all those fragments out of the soil core with water and collected them in the lab. We were able to collect them onto these strips of, or actually kind of tubes where we extracted and isolated these DNA fragments. So then you have these little DNA fragments that we want to read and figure out what species do these fragments correspond to. And so this is also in the lab, we're doing gene sequencing, where we can imagine if we find this little fragment here, and if we know the genome of a species, if we can match that genome to one species to the fragment, then that can actually tell us, oh, this DNA belongs to this species. And because we had that fragment in our soil core, then that species is present. And so this can allow us to say, okay, we actually know that we didn't find any DNA of this species, but we found DNA of these three species and not this one. So we did this. This is actually a picture for invertebrates, so like those fairy shrimp. These are seed shrimp. We did this for invertebrates that we found in the soil, and we also did these for plants that we found in the soil, and we found thousands of sequences of DNA. And we definitely found plants and animals that we'd never seen with our eyeballs out there. So it's really interesting to kind of do a deep dive and say, okay, actually, these were our neighbors at one point, even though they're not living here now. Are there ways in which we can promote allow them to live here again? So that's one way we can think about who are our neighbors, looking back in time and saying who used to live here. And then another way we can think about who our neighbors are, and again, thinking about that idea of extending the invitation, where you actually, at some point, you get to choose who your neighbors are, and looking into the future and saying, who do I want my neighbors to be? And this is really important to look into the future because our climate is changing and things are going to be different in the future than they are now and than they were in the past. And so if we are wanting to restore a vernal pool or community that's going to live and thrive in the future, we want to think about can these plants actually withstand the projected climate of an area? And there's this idea of climate matching restoration projects and saying, okay, if I know that the climate of Santa Barbara is actually going to become more like the climate of San Diego in the next like 50 years, then maybe the people and the plants and animals that want to live here are actually those that are adapted to this current San Diego climate. And so if we look at a map and see like, okay, I'm here in Isla Vista, which is in Santa Barbara. We have vernal pools here. You have a couple vernal pools in the Los Angeles area, like Madrono Marsh, which is where I talked with you last time. But then there's a lot more vernal pools in San Diego actually, in Miramar and Otay Mesa. And so my hypothesis was actually thinking about if the vernal pool plants that we found in San Diego might actually be able to withstand, to be adapted to the drought conditions that are projected for Isla Vista, for Santa Barbara, because San Diego already experiences a lot more severe drought. And so I wanted to test this hypothesis by setting up what we call a common garden, where I collected seed from all these three different populations and grew them together in a common garden. And I did this with Juncus bufonius, which is actually a pretty common rush. It is found in vernal pools, but it's found elsewhere as well. And so what I did was grew all these plants, put them in little pots, and then simulated, this is a tiny vernal pool, I simulated vernal pool conditions by putting these pots in a tray of water. And then I had an end of season drought treatment, which was a very severe drought where I would take the pots out of the water about at the same time that modeling the hydrology of the San Diego vernal pool, so that have experienced drought. And I call this one an end of season drought because I contrasted that with a mid-season drought treatment where I actually had the pots in the water, and then I took them out of the water for a little bit and then put them back in the water. And that was to simulate this kind of intermittent storms, which is projected for Santa Barbara. Kind of like what we've just seen, where we had some storms in November, we had a dry December until the last week of December, and then January, where we had 300% of our annual rainfall in 1 week. And then now it's been dry ever since. It's been 70s. So sometimes the pools dry out and then fill up and then dry out again. This is another type of drought. And so we had all of these pots set up. I gathered more human neighbors to help me monitor all these pots. And then we tracked how well they grew in these different drought treatments, really to see if these different populations could grow differently in these drought treatments, if they were adapted to these different drought treatments. So here I'm just showing these are the two treatments on the x-axis is mid-season drought, end-season drought. And then we just took above ground biomass of all of the little plants. So we just, once they were grown fully and then died, we collected their biomass and weighed them. And you'll see these three different populations in different colors. And what we actually see is that the different populations actually did respond differently to the droughts. So some populations, actually the San Diego populations, were able to grow more than the Isla Vista population under drought systems. So that kind of does support my hypothesis a little bit that maybe these San Diego populations are more adapted to drought. And so then the question becomes, should these be our neighbors? Should we welcome these San Diego native plants into Santa Barbara because they may be able to survive and thrive better in projected drought conditions? So that's a little bit of what I learned from my research in my local neighborhood vernal pools. Again, really thinking about who are my neighbors, who can I engage in restoration, what are we trying to restore, who are we trying to be good neighbors to? And I wanted to bring those questions into a discussion with you all about some other neighbors in your neck of the woods. So I'll just finish out my talk thinking a little bit about Gardena Willows Wetlands Preserve. And that is where I was yesterday. Actually, I got a awesome tour from Danielle Marquez from the Friends of Gardena Willows Wetland Preserve. And this is right in your backyard, right in your area. It's actually next to a food mart surrounded by a lot of urban development, but this is one remnant riparian wetland preserve. And I'll just take you through a tour of the Gardenia Willows and show you some pictures and talk with you a little bit about how we can be a good neighbor to this wetland preserve because it's a highly degraded space, but there is plans to do some restoration with the South Bay Parklands Conservancy and with my company, Vollmar Natural Lands Consulting. CNPS wrote a support letter in support of doing some more restoration in this preserve. And so we're really just asking the question today, what does it look like to be a good neighbor in Gardenia Willows? So as you walk along this road, you walk all the way down into this little gated area. It is gated off right now. It's not open for public use, and that's one first question of why is it gated off? Why is it an open space? And that has something to do with the city management. It is a city property. But that's the first question is like, can we actually open this up to be more neighborly? And then we also see that it's butted up. This is in the preserve now, but it's butted up right against some residential areas. And so you can immediately say, oh, hey, we like these are the physical neighbors of Gardenia Willows. It's fun to think about how we can get them engaged in the landscape. And as we start walking, we can see maybe some familiar faces. This is Encilia californica, California brittle-bush, which is a really common native species. So it's fun to see that in Gardenia already. And there's already been some restoration work by the Friends group to do some plantings and reintroduce natives into the preserve. But as we keep walking through and we actually get to the wetland portion, then we have, of course, the namesake willows. There's actually 4 different species of willows in the preserve, so it's really awesome to see that. But you can see that there's a lot of other stuff happening around here. All this foreground are these invasive annual grasses that I talked about before. Same ones in the vernal pools, not good neighbors. They are taking over the area. There's also this Cape ivy, not non-native, not a good neighbor. Really suffocates out a lot of native plants. And then as we actually move into some of the wetland area, there is some tule in the background, those tall bulrushes in the background. That's a really awesome native plant to have. But some of the area, actually most of the wetland area is being choked out by Ludwigia, water primrose. Not a good neighbor. It is also a non-native and really takes over can grow again rhizomatously, so it can grow really quickly across the water. And another reason why it's not a good neighbor, not only to the native plants but also to animals and other things living in the water, is that it shades out the whole water column and makes it really hard for anything else to get light or photosynthesize or do any activity. And so you get kind of a boggy, choked up landscape and definitely slows down the water, which creates some pools like this one here, that become pretty stagnant water pools that become breeding grounds for mosquitoes, which I don't really like having mosquitoes as neighbors. So it's not the best situation here where we would want to see kind of flowing water, but here this water is just kind of pooling and getting clogged up. And you can see that it actually, the Gardena Willows wetland is actually collecting a lot of urban runoff from the surrounding area. So that's how it's actually being a really good neighbor. It's actually acting as flood control, where any excess water gets channeled into some culverts and then gets put into the wetland itself. And so we can think about, well, where is this water coming from? Are there native species or invasive species that upstream that are getting pumped into this ecosystem? So how can we expand our view of the Willows Wetland Preserve and think about like on a community scale? It's really important to engage with the neighbors, the other landowners around, to think about what's coming into Gardena Willows. So we can wander around a little bit more, and we come to this beautiful patch of gallium, which bedstraw, which is a native species. It's a really fun little native species. So that is providing a really good, healthy understory here. You can see it as actually kind of making a monoculture. And so in general, we would want a little bit more diversity, but at least there is this native, and you can see it's a little bit more patchy. There's some open areas for other species to come in. Unfortunately, there are some non-native grasses coming in the background, but we can imagine like what other native plants could we add into this area. And then is some upland area to the preserve, and there's these beautiful oak woodland groves that are just really great spaces for bringing out family and friends. I imagine this is a great gathering space to engage with your neighbors in that way. So it's really fun to, again, think about who could you invite to Gardena Willows to get invested in this community. And then I think second to last picture is another wetland area where they've actually done some restoration. The Friends group has already done some restoration work here, where they've actually taken out that Ludwigia, the invasive water primrose. So you can see just a little tiny bit of it coming back, but you can see there's more space for these tule, these long reeds to come up. Sorry, these long rushes to come up. And provide native habitat for some native animals. And the last picture I wanted to show you of Gardena Willows is this gorgeous mural that was made in the back of Gardena Willows. This was made by a school group, a bunch of 8th graders. So the Friends group actually works with a bunch of environmental charter schools to bring out these kids to help to become good neighbors of this landscape, to help steward it, to do weeding, to do planting, and to really imagine this space as their home, not just a neighbor, but actually a part of their home. And they got to imagine like what they would really want to see in this landscape, and also inspired by some of the indigenous culture here. So I just want to end with that image, and just think about what you all would like to see in Gardena Willows, how you think you could be engaged as a neighbor in Gardena Willows. And if you want to really get your hands dirty and get involved, then definitely reach out to the Friends group and keep in touch with me and CNPS and South Bay Parklands Conservancy, as we are doing more restoration in this area. So I'll end my talk there, but I'm happy to stay on. I'm not quite sure how long you guys go, but happy to stay on for questions. I see some questions popping in the chat, so I can start with those. Unless Brent, do you want to say something else?
No, I think if you want to ask a question, you can drop it into chat, or you can just unmute yourself and step on into the conversation. Joanna's very friendly, and there's no question that's too small. But there was a question that I had from our chat over here, and Karen Hussman was saying, not even the city knows where water comes from in our New Hampshire pond, in quotes. So I've been told. So my first question back to her was, is New Hampshire pond a local term for the Gardena Willows?
It is, Yeah, it's our informal term
Oh,
for that the pond where the big pipe comes in.
yeah.
And it was Cheryl Sherman who told me that the Public Works doesn't have like a map for all of it. Of course, some of it may come in from the city of Los Angeles, which is just New Hampshire is the street that runs parallel to Vermont, and Vermont is the city boundary on the eastern boundary of Gardena. And because the street is New Hampshire and it dead ends into, the Willows there, and someone, you can actually like walk along the street and look into the Willows, like if it's closed and you can't get in, you could see a good part of it there.
Hmm.
But we just call it the New Hampshire Pond, and it's kind of an anomaly because most of the drainages into the Willows are like an open drain, like an open concrete channel that comes down from a street, and then at the bottom there are rocks. And I think what happened, because this one is a big pipe, and that part of the street, I think what happened was it was never developed, or the street was never finished properly because, oh, we're just going to put a convention center on it, or we're going to build something on it. We're going to take all this junk of trees and ugly trees and things and swampy water, and we'll just pave it over and build something. So it was it's kind of an unfinished street, and in recent years, the Public Works has done a little more to put proper drainage and try to help better drainage. But that, I think what happened is that the pipe washed away some rocks that were down there. Like, because that's a pretty big pipe, and I think it has pushed and hollowed that out in front of it. In my opinion, I think it should just be filled up with rocks or maybe reconfigured in some way. But I'm no expert, and I mean, the Public Works people are nice, but the city isn't always prioritizing things the way I would like for some
Yeah,
reason.
that's so true. And that was another question I was like kind of would like to pose to the group too is like, again, who is your neighbors? Like the city is definitely your neighbor in this situation. And the Friends group has been doing a lot of work to really foster a good relationship with them and really include them in the conversation and figure out how to work with them. Yes, they don't always have the same priorities, but they are really an integral part of figuring out how to manage this land. And they actually do have maps of the all the different drainages in the area, and so we can try to figure out how that fits into the larger landscape. They have it just for the Gardena property, and so I'm not as familiar with all the surrounding streets and neighborhoods, but that's definitely something we could try to piece together.
Yeah. Another part of Karen's question was, what are the 4 species of willows? She's only been told of 3.
No, that's a good question. Danielle told me there are 4. There's definitely Salix lazulapis, the arroyo willow, and um I'm not sure. Karen, what were the 3 that you know of
So
actually?
the black willow, or sometimes Gooding's black willow,
Yeah.
and I guess some people want to drop the Goodings part out of it or something. And then I was told there's this narrow leaf willow, which no one, people talk about the first 2 species, but no one would talk about the narrow leaf willow, which is
Hmm.
kind of, it's smaller and it's a little tougher, and, I think, but
Salix
as I
exigua.
looked at it, when I've looked at pictures like on CalFlora of willows, it almost looks like it's not. And then I'm like, I have no idea what a 4th species would be unless it was maybe red willow, or I don't know.
It might be, yeah, that's what I was thinking. It might be red willow in there.
This is Tony.
Yeah.
The narrowleaf is the Salix exigua.
Hmm.
There's probably Lasiandra as well.
Okay. Yeah, so there is I was surprised by the amount of native diversity in there, with both the trees and some good coastal sage scrub. There was a lot of sages in there, some coyote bush. Um, so it's a good palette to start with for sure.
Yeah, well, in the early 2000s or way back, there was a big restoration where it was planted with irrigation and all that.
Hmm.
I mean,
Hmm.
the willows were always there, but then they added a bunch of stuff. And so so a lot of the plants that are there were added with the restoration.
Yeah.
But we do have some that were other than the willows that were there all along. The mugwort, there's a
Yeah, there's
mugwort.
really good
Cheryl
mugwort.
Sherman was always just gloating over it because it's like she said they were there all along, and and they've survived because we thought that they're kind of a shade plant. And when the a shot hole borer was found, and we just had a terrible time there because we were supposed to take all of the diseased, affected trees and cut them all down, and we removed most of the arroyo willows, and we were cutting down all kinds of trees, and so all there's this sunlight. Well, the mugwort seemed to like it better that way.
Yeah. Yeah. It's fun when you can clear out an area and see what can grow in there. And hopefully it's natives that are growing back there. So yeah, I definitely saw a lot of mugwort. And of course oaks were there as well previously. So trying to foster good habitat for the oaks.
Yeah, Brian Haig says, thank you, Joanna, for a great presentation and your commitment. And Dee says, beautiful presentation. I appreciate your use of student interns and sharing the techniques you used and graphing what occurred with the work you did near UCSB.
Yeah. If you want more
Ellen?
data, I can always give you more data. I was jamming a lot into this one talk, I do confess. So, happy to have any follow-up questions.
So, well, maybe you could explain a little bit about your plots. That you're using a box plot technique, which is the box extends like up and down
Oh, yes.
one
Yes.
quartile or something like that.
Yes, interquartile ranges. Sorry, my PowerPoint is actually frozen, so I can't go back. But it's basically like a bar graph, but with bar graphs you use medians as kind of the middle line. In box graphs, in bar graphs you use the mean as the middle line. In box plots, you use the median, and that's because in messy plant data and ecological data, medians usually actually represent the middle of the data a little bit more. And then I like having the box plot because it does show the amount of variation and the interquartile variation. I think it just gives you a little bit more information about the variability in the data set.
What do those vernal pools near UCSB look like now? Did they continue with maintenance? Did you manage to hand that task off?
I did not manage to hand it off, and I miss them dearly. I am trying to look for grants to be able to continue working with them. I just sent out an intern to monitor the hydrology because I was like, at least we need the hydrology after these storms. There are definitely still the native plants that we seeded in there, but we haven't been able to seed anymore. But now that there are larger populations, hopefully they can be a little bit more self-sustaining. Um, but the grasses, the invasive grasses definitely liked the early storms. Like as soon as the first storms hit, they kind of popped up right away. Some of them may have gotten flooded out actually, like they were too eager, so maybe they got flooded out during these storms. Um, but I would love to continue engaging in them. And that is a really hard part about being a good neighbor and being invested is it is a commitment. It does take a lot of time and money usually. Um, and yeah, you do have to choose, you just have to figure out how to prioritize um, how you engage in your community.
So George's vernal pools were small enough that he would have his students go by and use scissors to just kind of cut off the invasive
Yeah.
plants at soil level to
Uh-huh.
prevent the seeds from getting in there. I
Yeah.
don't think that technique works too well in a bigger pool like you were showing.
Yeah.
How would you mitigate that? The seed bank.
Yeah, that's where, yeah, weed whacking comes in. That is the main tool, is going out there with a weed whacker or a mower. And as you get bigger and in a more kind of contiguous landscape, again, that's where fire is really useful. or grazing is really useful. So the raking treatment was actually trying to find an analog on a relatively smaller scale. Yeah, kind of that in between of hand pulling and fire and cattle. What's that in between? So that's how we settled on that raking treatment.
So what's next? What's next for you? It sounds like you have something brewing with Gardena Willows, and you told us earlier about a um, French broom removal project.
Scotch broom, yeah.
A
Mhm.
Scotch broom, okay.
Yeah. So with the Gardena Willows, the South Bay Parklands Conservancy applied for a community wetland restoration grant, and that we got favorable reviews, and we are just waiting on the disbursement of Prop 4, the climate bond bill, Prop 4 money. So figuring out the logistics of that. But once we get that money, then we really want to focus on doing more restoration in those pooled areas, kind of the mosquito breeding ground areas, of really getting out that invasive primrose, and figuring out how to get the water flowing a little bit more to promote a more native habitat, and hopefully plant more native species as well.
All right, well, that's exciting. So it sounds like we may be seeing some more of you.
Yes, I hope so. Yeah. And if you yeah, go and check out Gardenia Willows, then definitely get in touch with the friends group. And keep your eyes peeled for what's happening in Gardenia.
Okay. If there's any last questions, Gerard is saying he loved the presentation.
Thanks.
He's down in San Diego County right now with his daughter and his maybe his son-in-law or daughter's family, and they are CNPS members as well.
Cool. Yeah, there are a lot of great vernal pools down in San Diego near Oceanside, so you should get out and see them.
Yeah. Okay. Well, if there's no more questions, then I think we'll adjourn. And thank you so much.
Yeah, thanks for having me. Always a pleasure.
All right. Likewise.
Thank you for your time.
Thank you.